delivering quality education, expanding access to learning. The official TV-based instruction of Tagum City. This is Tagum City Division's DepEd TV. Tara na!
Hello, our dear learners. Today is another day for a new and digital way of learning in the world of mathematics. I am so glad to be part of your journey as you discover new lessons through television. Airing from Tuason TV Escuela, I am your teacher on air, Teacher Kim Navarro from Jose Tuason Jr. Memorial National High School in the service of DepEd Tagum City. Aiming to continue education amidst the challenges brought by the pandemic, together we will master our competencies while staying at home. So what are we waiting for? Let's start the lesson. Our lesson for today is all about mutually exclusive and not mutually exclusive events. Module 4 of Quarter 3. Let us learn while having fun. Indeed, expect a meaningful learning. Learn plus fun equals meaningful learning. After going through this module, you are expected to illustrate mutually exclusive events and non-mutually exclusive events. Solve word problems involving mutually exclusive events and non-mutually exclusive events. Before we delve deeper to our lesson, let us try answering the pretest, which will measure your previous knowledge about the topic. Please answer what is asked. You will be given 5 seconds to answer each problem. And when you hear this sound, then time is up. Are you ready? Please make sure that you have with you your Quarter 3 Module 4 Self-Learning Module, your pen and a paper. Okay? Let's begin. In rolling a die, which of the following illustrates mutually exclusive events? A. Getting an even or odd number. B. Getting an even number or divisible by 3. C. Getting 4 or even number. D. Getting 2 or a number less than 5. The answer is letter A, getting an even or odd number. Number 2. A card is chosen at random from a standard deck of 52 playing cards. Which of the following illustrates not mutually exclusive events? A. Choosing a spade or a heart. B. Choosing a queen or a king. Choosing a face card or an ace. D. Choosing a diamond or a queen. Your time starts now. The answer is letter D, choosing a diamond or a queen. Number 3. Mutually exclusive events have no outcomes in common. A. True. B. False. C. Maybe. Or D. Needs more information. Your time starts now. The answer is letter A, True. Number 4. A non-transparent bag contains 6 black beans, 4 red beans, and 5 white beans. If a bean is picked from the bag, what is the probability of getting a black or a red or a white bean? A. 0.3, B. 75%, C. 0, or D. 1. Your time starts now. The answer is letter D, 1. Number 5. Out of 120 senior high school graduating students, 30 are on the honor roll, 25 are members of the Tuason Dance Society, and 15 are in the honor roll and are also members of the Tuason Dance Society. What is the probability that a randomly selected senior high school graduating student is on the honor roll or is a member of Tuason Dance Society? A. 30 over 120, B. 1/3, C. 5/6, D. 5/24. Your time starts now. The answer is letter B, 1/3. Congratulations for performing well. It's time to move forward. This time, let us study what are mutually and not mutually exclusive events. Events that have no outcomes in common are called mutually exclusive events. This means that two events cannot occur at the same time. This is also called disjoint events. For example, you can't run backwards and forwards at the same time. The events running forward and running backwards are mutually exclusive. Consider this Venn diagram. What do you notice about these two events A and B? These two events are mutually exclusive. If two events A and B are mutually exclusive, then the probability that either A or B occurs is the sum of their probabilities. In symbols, the probability of A or B equals the probability of A plus the probability of B. Let's have this example. In rolling a die, getting an odd number or even number, the sample space or the possible outcomes in rolling a die are 1, 2, 3, 4, 5, 6. Odd numbers are 1, 3, 5, and even numbers are 2, 4, 6. By looking at the illustration, the two events have no outcomes in common. Thus, these two events are mutually exclusive. To find its probability, just add the probabilities of two events. Probability of an odd number or an even number is equal to the probability of an odd number plus the probability of an even number. That is the probability of A or B equals the probability of A plus the probability of B. Then, the probability of A is the n of A or the number of odd numbers over the n of S or the number of all possible outcomes in rolling a die. That is 3 over 6 or 1/2. Then, the probability of B is the n of B or the number of even numbers over the n of S. That is 3 over 6 or 1/2. After that, perform the operation. 1/2 plus 1/2 equals 1. Therefore, the probability of getting an odd or even number in rolling a die is 1. On the other hand, two events A and B are said to be not mutually exclusive events if both events A and B have at least one common outcome between them. For example, can you sing and dance at the same time? Yes, of course. These two events of singing and dancing are not mutually exclusive. Take a look at this Venn diagram. What do you notice about the events A and B? Are these two events not mutually exclusive? Yes! As you can see in the illustration, the two events have common outcomes. Thus, these two events are not mutually exclusive. If two events, A and B, are not mutually exclusive, then the probability that either A or B occurs is the sum of their probabilities decreased by the probability of both occurring. In symbols, the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. Let's have this example. In rolling a die, getting a number divisible by 2 or a number less than 5. The possible outcomes in rolling a die are 1, 2, 3, 4, 5, 6. So, there are 6 number of outcomes in the sample space. If we let A as the numbers divisible by 2, the outcomes are 2, 4, 6. So, we have 3 number of outcomes in this event. If we let P or the numbers less than 5, the outcomes are 1, 2, 3, 4. So we have 4 outcomes in this event. By looking at the Venn diagram, the two events have 2 common outcomes. These are 2, 4. Thus, these 2 events are not mutually exclusive. To find its probability, just add the probabilities of 2 events minus the probability of both occurring. So, the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. Next, find the probability of A or the probability of getting a number which is divisible by 2. Since there are 3 number of outcomes for event A, therefore, the probability of A is 3 over 6. Where did we get 6? Take note that in rolling a die, the number of possible outcomes is 6. Hence, the denominator is 6. Then, the probability of B is 4 over 6. Since there are 4 number of outcomes in getting a number less than 5, after that, find the probability of A and B or the common outcomes of the 2 events. Since there are 2 common outcomes in these 2 events, which are 2 and 4. Therefore, the probability of A and B is 2 over 6. For easy solving, do not reduce each fraction to lowest term. Since the resulting fractions are similar, just simply add or subtract the numerator and copy the denominator. So we add 3 and 4. That is 7, then subtract it by 2. So the probability of A or B is 5 over 6. Therefore, the probability of getting a number which is divisible by 2 or a number less than 5 in rolling a die is 5 over 6. This time, let's have another illustrative examples. In a deck of 52 playing cards, these are divided into 4 suits of 13 cards each. These are clovers, spades, hearts, and diamonds. Cards of spades and clovers are black cards. Cards of hearts and diamonds are red cards. The card in each suit are King, Queen, Jack, 10, 9, 8, 7, 6, 5, 4, 3, 2, and ace. King, queen, and jack are face cards. If a card is drawn from a well-shuffled pack of 52 cards, find the probability of the following. Number 1, a king or a queen. Event A refers to cards which are king. These are king heart, king diamond, king spade, and king clover. With that, N of A, or the number outcomes in drawing a king, is 4. Event B refers to cards which are queen. These are queen heart, queen diamond, queen spade, and queen clover. With that, N of B, or the number outcomes in drawing a queen, is 4. Since drawing a king or a queen has no common outcomes, hence, it is an example of mutually exclusive events. So, the probability of a king or a queen, that is the probability of A or B, equals the probability of A plus the probability of B. That is N of A over N of S plus N of B over N of S. N of A refers to the number of king cards, and that is 4, while N of S refers to the number of all possible outcomes from a deck of cards, which is 52. Hence, the probability of A is 4 over 52. The probability of the second event is also 4 over 52. Since the number of queen cards from a deck of 52 cards is 4. Next, add the resulting similar fractions by adding the numerator and copy the denominator. That is 4 plus 4 equals 8. Then copy the denominator 52. Then, reduce to lowest term by dividing both the numerator and denominator by 4. So, the probability of A or B, or the probability of drawing a king or a queen from the deck of cards, is 2 over 13. How about if you draw a jack or a heart card? Is drawing a jack or a heart card has common outcome? Are these two events representing a not mutually exclusive events? Let's check. Event A refers to cards which are jack. These are jack heart, jack diamond, jack spade, and jack clover. With that, N of A, or the number outcomes in drawing a jack card, is 4. Event B refers to cards which are heart. These are ace heart, 2 heart, to 10 heart, then jack heart, queen heart, and king heart. With that, N of B, or the number outcomes in drawing a heart, is 13. Now, try to observe the common outcome. Do they have a common outcome? Yes, there is, and that is the jack heart. Hence, these two events are not mutually exclusive. The number of common outcome is 1, so N of A and B equals 1. To find its probability, just add the probabilities of two events minus the probability of the common outcome. So, the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. That is N of A over N of S plus N of B over N of S minus N of A and B over N of S. The probability of event A is 4 over 52, since there are 4 jack cards from a deck of 52 cards, while the probability of event B is 13 over 52, given that there are 13 heart cards. Then, the probability of A and B is 1 over 52, since there is only one common outcome of events A and B. Next, perform the resulting similar fractions. Add 4 plus 13, that is equal to 17, then minus 1. The answer is 16. Then copy the denominator, which is 52. So, the resulting fraction is 16 over 52. Subsequently, reduce this to lowest term by dividing both the numerator and the denominator by 4. Therefore, the probability of A or B, or the probability of drawing a jack or a heart card from the deck of 52 cards is 4 over 13. Now, it's your turn to answer this. Find the probability of drawing a face card or a diamond card from a deck of 52 cards. I'll give you 10 seconds to answer. What is your answer? Let's check if your answer is correct. Are these two events mutually exclusive or not mutually exclusive events? Let's check. Event A are face cards. These are Jack Heart, Jack Diamond, Jack Spade, or Jack Clover, Queen Heart, Queen Diamond, Queen Spade, Queen Clover, King Heart, King Diamond, King Spade, and King Clover. With that, N of A, or the number outcomes in drawing a face card, is 12. Event B are cards which are diamond. These are Ace Diamond, 2 Diamond to 10 Diamond, then Jack Diamond, Queen Diamond, and King Diamond. With that, N of B, or the number outcomes in drawing a diamond, is 13. Now, try to observe if there are common outcomes. Yes, there are common outcomes. The common outcomes are Jack Diamond, Queen Diamond, and King Diamond. Hence, these two events are not mutually exclusive. The number of common outcomes is 3. So N of A and B equals 3. So, the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. That is N of A over N of S plus N of B over N of S minus N of A and B over N of S. The probability of event A is 12 over 52, while the probability of B is 13 over 52. Then, the probability of A and B is 3 over 52. That is 12 over 52 plus 13 over 52 minus 3 over 52. Next, perform the resulting similar fractions. Add 12 plus 13, that is equal to 25, then minus 3. The answer is 22. Then copy the denominator, which is 52. So, the resulting fraction is 22 over 52. Afterward, reduce this to lowest term by dividing both the numerator and the denominator by 2. Therefore, the probability of A or B, or the probability of drawing a face card or a diamond card from the deck of 52 cards is 11 over 26. Is your answer correct? Wow! Very good! Math pinagaling! Remember that events can be mutually exclusive or not mutually exclusive. If two events A and B are mutually exclusive, then the probability that either A or B occurs is the sum of their probabilities. In symbols, probability of A or B equals the probability of A plus the probability of B. On the other hand, if two events A and B are not mutually exclusive, then the probability that either A or B occurs is the sum of their probabilities decreased by the probability of both of them occurring. In symbols, probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. Now that you have understood how to find the probability of mutually and not mutually exclusive events, so this time, let us check your understanding. Let us assess your learning by answering this problem. You will be given time limit for each problem. Let's begin! Problem number 1. In rolling a die, which of the following illustrates mutually exclusive events? A. Getting a number divisible by 2 or a number divisible by 3. B. Getting a prime number or an even number. C. Getting 4 or a number less than 5. D. Getting 3 or a number divisible by 2. This will be answered for 5 seconds. Your time starts now. Time is up! The answer is letter D, getting 3 or a number divisible by 2. Problem number 2. A card is chosen at random from a standard deck of 52 playing cards. Which of the following illustrates not mutually exclusive events? A. Choosing a black card or a diamond. B. Choosing a heart or a spade. C. Choosing a clover or a queen. D. Choosing a 10 or a face card. This question will be answered for 5 seconds. Your time starts now. Time is up. The answer is letter C, choosing a clover or a queen. Problem number 3. From a standard deck of 52 cards, find the probability of picking a red card or an ace card. A. 7/13. B. 8/13. C. 9/13. D. 10/13. Answer this problem for 10 seconds. Your time starts now. Time is up. The answer is letter A, 7/13. Problem number 4. Using the table of profiles of a sample of 5 patients in Darbo Medical Center, DMC, what is the probability of housing a male or 16-year-old patient in DMC? A. 1/5. B. 2/5. C. 3/5. D. 4/5. This will be answered for 10 seconds. Your time starts now. Time is up. The answer is letter D, 4/5. Problem number 5. Using the table of conditions and profiles of a sample of 5 patients in Darbo Medical Center, DMC, what is the probability of housing a female or a patient with a sore throat? A. 1/5. B. 2/5. C. 3/5. D. 4/5. Answer this for 10 seconds. Time starts now. The answer is letter C, 3/5. What's your score? Very good, students! Congratulations! You deserve a round of applause for demonstrating skills in solving problems involving mutually and not mutually exclusive events. I hope you enjoy our discussion today. Let's keep learning math with fun and excitement. Math pinasaya, math pinagaling. As a point of reflection, let me borrow Brian Herbert's line. The capacity to learn is a gift. The ability to learn is a skill. The willingness to learn is a choice. That ends our lesson for today. This has been your teacher on air, Teacher Kim Navarro. See you in next episode only here at Tuason TV Eskwela.